Welcome back to The Explainer. So today, we're taking a deep dive into a piece of technology that you literally use every single second of your life, but you probably rarely think about it as hardware. I'm talking, of course, about your own brain. Now, as our species is hurtling toward becoming a Type I civilization, one that can harness the energy of an entire planet, we are actually still running on some pretty incredibly old legacy biological hardware. Think of the human mind as our species' ancestral operating system. It's insanely powerful for sure, but it's also loaded with ancient code, some really weird unexpected glitches, and entirely hidden developer menus. And today we're going to map the whole thing out together.
We've set up this explainer to be a complete diagnostic scan of the mind. We'll start with Section 1, the biological OS. Then Section 2, hacks and heuristics. Section 3, glitches in the system. Section 4, which we are going to focus heavily on today, dreams and virtual realities. And finally, Section 5, near-death experiences, the final threshold.
Okay, let's jump right into Section 1, the biological operating system.
Let's look under the hood at the actual processing power of our biological hardware. You might feel like you're consciously in control of most of your daily decisions, right? Well, the numbers tell a completely different story. Just look at this massive number here, 11 million. That is the number of bits of information your subconscious intuition processes every single second. 11 million. Now contrast that with your conscious mind, which handles a measly 40 to 50 bits per second. So when you get a gut feeling about something, it's not magic. It's literally your biological OS doing high-speed, massive-scale pattern matching in the background, drawing on a mountain of sensory data you aren't even consciously aware of.
But here's the catch. That massive background processing includes some incredibly old survival mechanisms. Take nyctophobia, for example, the fear of the dark. Unlike cats or dogs, humans are completely missing a tapetum lucidum. That's the reflective layer in the eye that gives animals night vision. So in the dark, our primary sense is just neutralized, and our evolutionary programming responds by triggering an automatic, hypervigilant alert state in the amygdala. Honestly, if we're ever going to successfully colonize deep space, which, let's face it, is perpetually pitch black, we have to figure out how to manage this deeply embedded base code. Because we can't see well in the dark, our brain basically just cranks up the gain on all our other senses. It completely prioritizes safety over accuracy. A random shadow or a weird sound? Boom, pupil dilation, huge cortisol surges, and this fascinating glitch called pareidolia kicks in. That's our brain's hardwired tendency to find faces in random patterns. It's why, in low light, that coat rack in the corner suddenly looks exactly like a masked intruder. It forces a massive fight or flight response before your conscious 50-bit per second mind can catch up and remind you, hey, we just bought that coat rack at IKEA yesterday.
And this brilliantly illustrates how even our most profound, magical human experiences are fundamentally just algorithmic. Take love and attraction. We romanticize it, but it's literally a step-by-step biological program to ensure species survival. Step 1, lust, driven right from the hypothalamus. Step 2 moves into this intense, dopamine-fueled obsession phase of attraction. And finally, Step 3 settles into long-term attachment, which is mediated by oxytocin. We even subconsciously pick our partners based on the scent of their immune system genes, the MHC genes, just to guarantee genetic diversity for our offspring. It's all programmed in.
Oh, and here's another incredible piece of legacy code. Frisson. You know those musical chills or goosebumps you get during an absolutely amazing song? Why on earth do acoustic sounds give us physical chills? Well, it turns out it's just a repurposed ancestral thermoregulation reflex. When a song surprises us, like a sudden key change or a crazy vocal jump, it triggers a mild startle response. But then, a split second later, the brain realizes it's a beautiful sound, not a predator. So it bridges the auditory cortex right to the reward center, dumping a ton of dopamine into your system. Just imagine a Type I civilization using engineered soundscapes to instantly synchronize the emotions of an entire population.
All right, moving on to Section 2, hacks, heuristics, and placebos. So because our biological OS relies so heavily on subconscious processing and chemical rewards, it is wide open to being influenced, manipulated, or just completely hacked. And the most undeniable proof of this is the placebo and nocebo effects. Your brain essentially runs its own internal pharmacy. With the placebo effect, pure optimism and trust can literally trigger the release of natural opioids and dopamine, resulting in genuine, measurable physical healing. But it has a dark twin, the nocebo effect. This shows that anticipatory anxiety can trigger cortisol drops that cause real physical distress and pain entirely because you expect it to. Belief isn't just a concept, it is literally a biological programming language. And if internal belief can hack the body, external social structures can absolutely hack the mind. The BITE model of mind control is a perfect example. It breaks down the structural mechanics used by high control groups and cults. They systematically regulate your behavior, restrict information, use loaded language to shut down critical thought, and leverage guilt for emotion control. By executing these 4 steps, these groups completely bypass individual critical thinking. It is essentially an algorithmic override of personal autonomy, forcing total group allegiance.
And the induction process for these groups exploits our biology so perfectly. It usually starts with love bombing, just flooding the target with artificial belonging to spike that exact same dopamine system we talked about earlier. Then later, if the group's predictions completely fail, members experience cognitive dissonance. Instead of leaving, they actually double down on the false narrative just to protect their core identity. And guys, today, this isn't just happening in remote off-grid compounds. It is happening globally through digital algorithmic echo chambers. Finding a way to maintain social cohesion without falling into this kind of collective stagnation is going to be a totally critical survival metric for our future.
Which brings us to Section 3, glitches in the system.
Okay, so we've got the base code, and we've seen how it gets hacked. But what happens when the human operating system just has a rendering error? We have all felt it. Déjà vu. But the crazy thing is, déjà vu isn't a standard memory at all. It's actually a data clash. It's a conflict between a profound sense of familiarity and your conscious, logical knowledge that you are definitely experiencing this exact moment for the very first time. It completely bypasses the hippocampus, which is the who, what, and where center of your memory. And instead, it misfires in the rhinal cortex, which just handles the raw, unfiltered signal of familiarity.
Now, neurologists generally look at 2 leading theories for why this happens. The dual processing theory suggests there's a millisecond delay in the brain's timing. So the current moment accidentally registers in your long-term memory a fraction of a second before it even hits your conscious awareness. It's literally a data collision. Then there's the hologram theory, which suggests just one single element, like a specific smell or a shadow, triggers a generalized feeling of familiarity for an entirely new room. Philosophically, though, it really makes you wonder, are these just mundane sensory archive errors, or are we experiencing literal simulation state refresher?
And that scales up to the macro glitch, the Mandela effect. This is where massive populations remember history completely differently than recorded reality. People vividly, swearing on their life, remember the Berenstain Bears being spelled with an E, or Darth Vader saying, "Luke, I am your father," when the actual dialogue is, "No, I am your father." Theories for this divergence are all over the map. They range from psychological confabulation, where our brains just logically fill in the blanks, to parallel quantum realities rubbing together, or even minor code updates in a simulated universe. Whatever the cause, the sheer divergence between objective reality and human recollection is pretty staggering.
Let's transition into Section 4, Dreams and Virtual Realities.
Now, I want to spend a little extra time on this section today because if our waking life is susceptible to glitches, you have to ask, what happens when the system intentionally goes into offline maintenance mode? Modern neuroscience actually views dreams as this crucial sandbox environment for memory consolidation and threat simulation. In a standard dream, your logic center is just powered down. You're a totally passive observer riding a very weird scripted roller coaster. But in a lucid dream, that's when the developer menu opens. Your dorsolateral prefrontal cortex actually reactivates while you are still fast asleep. You cross the threshold from passive observer to active participant, literally able to intentionally modify the physics and the environment of the dream itself.
Think about it. Lucid dreaming is essentially a fully biological virtual reality that's been built into our hardware from the start. To achieve it, practitioners use something called reality testing, which is basically looking for environmental inconsistencies while awake, much like hunting for rendering errors in a video game, so they trigger awareness while asleep. And mastering this state, it's deeply relevant to our technological future. Advanced brain-computer interfaces, BCIs, are currently aiming to stabilize these exact neural states for intense creative problem-solving. It acts as the ultimate bridge between our biological human heritage and true digital consciousness. It's the ultimate biohack.
Finally, we arrive at Section 5, NDEs, the final threshold. We've explored the legacy software, the social hacks, the memory glitches, and the offline VR mode. But what about the ultimate absolute edge case? What actually happens when the biological hardware shuts down completely? When a person approaches death or is declared clinically dead with absolutely zero measurable brain activity, how is it possible that conscious awareness often persists? Not only persists, but produces some of the most intense, hyperlucid, life-altering psychological events a human being can possibly endure. The most important thing to grasp here is that this is no longer just anecdotal folklore. It is a highly measured clinical phenomenon. Using standardized tools like the Grayson scale, researchers actually quantify features of these experiences. Things like panoramic life reviews, a total and sudden cessation of physical pain, and encounters with seemingly non-physical environments. But the real kicker here is the clinical AWARE study. It essentially verified that conscious awareness can actually persist for several minutes after the heart completely stops beating. That's a window of time where medical science previously considered the brain to be entirely inactive and incapable of generating complex thought.
Naturally, the scientific community is deeply divided on what this means. On one side, you have the biological theory. This posits that an NDE is purely a physical glitch, a sort of last-ditch system dump. A massive flood of endorphins and DMT-like compounds, combined with severe oxygen deprivation, which causes tunnel vision and hyperrealistic hallucinations. But on the other side, you have the transcendental theory. This suggests the non-locality of consciousness. It implies that the mind might actually be substrate independent, meaning it is fundamentally capable of existing outside the physical hardware of the brain.
And that brings us to the ultimate question we have to face. For a civilization that's actively looking toward mind uploading and achieving Type 1 status, this is the grand crossroads. If consciousness is purely a product of neural activity, well then our operating system can eventually be digitized, backed up, and transferred. But if near-death experiences are actually pointing to a non-local field of consciousness, our entire evolutionary roadmap is fundamentally completely different. So I'll leave you with this. Are we just incredibly complex biological machines waiting for a digital download? Or is there an entirely separate layer of reality that our operating system is only just beginning to access? Thank you so much for exploring the human operating system with us today. Keep questioning your reality, and we'll see you next time.